All right, thank you so much for joining us today. So in preparation towards our final exams, we are taking questions to prepare us to take our exams with confidence. So I have 7 questions, which is section B on differential equation. Let's jump right in and let's solve. So first question here, we want to find a general solution, right? So that's basically what we just want to do. But we see that this function that, or this differential equation here, is the linear first order, right? So we need to write this one as y prime plus gen of x, y is equal to h of x, where our mu is equal to e to the power gen of x dx. So we need to make sure that we have this function of this form so that we can get our gen of x. So I can write it as y prime minus 2y is equal to x. Then my gen of x will be equal to minus 2. So this one will help me to find my mu, which is the integrating factor, e to the power minus 2 dx. And when I integrate this, I'm going to have e to the power minus 2x. So this is my integrating factor. So I'm going to multiply the integration factor throughout this equation. I'm going to write the y prime as dy over dx. So I'm going to have e to the power minus 2x dy over dx minus 2y e to the power minus 2x, which is equal to x e to the power minus 2x. So now we have the standard form for when solving first order linear differential equation. So when we want to do this, we are going to combine this one together. So I'm going to ignore this one and just write this one, but I'm going to write it this way: d of dx y e to the power minus 2x. So I said anytime you are dealing with first order, ignore this one, and here take the y here and multiply it by this, which is the one in here, and it will be left with d over dx out here. And when I do the product rule here for the differentiation, I'm going to have this right here. So this is the same as x e to the power minus 2x. So for us to get our solution, we need to integrate both sides with respect to x. So with respect to x, and this is what we are going to get from this. Now, what can we do again? Now, with this, we can cancel this and that. So we are going to have this minus 2x, which is equal to x e to the power minus 2x dx. Now, for us to integrate this, we need to use integration by part. So we know that integration by part, u dvn is equal to u vn minus vn du. So now let's pick our u. We are going to pick u to be x, and then dvn to be equal to the exponential function 2x dx. Now from the equation here, we need u. Sorry, this one's supposed to be vn. We need vn and we need du. We can get du from this, and we can get vn also from this. So du over dx is equal to 1. This implies that du is equal to dx. And here we need to integrate both sides because we need vn, right? So we are going to have something like this, and this vn will be equal to e to the power minus 2x divided by, so when I'm integrating an exponential function, what I need to do is maintain the function and divide it by the derivative of the exponent. And when I differentiate the exponent, which is minus 2x, I'm going to have negative 2. So what are we going to get? We are going to have y e to the power minus 2x to be equal to, so this, we are going to use the integration by part to do that. So this times this is going to give us x e to the power minus 2x divided by minus 2 minus integral of vn. Vn is this times du, which is also equal to this. So I'm going to have e to the power minus 2x divided by minus 2 dx. So let's try and simplify this. Minus x e to the power minus 2x divided by 2 plus 1 over 2 integral of e to the power minus 2x dx. What can we get from here? Minus e to the power minus 2x divided by 2 plus 1 over 2. Then when I integrate this, the same idea, maintain the function, right? And divide it by the derivative of what is on the top, then plus a constant. So this is what I'm going to get. Let's try and simplify it and see what we are going to get at the end of the day. Minus x e to the power minus 2x divided by 2 plus, no, it's going to be minus 1 over 4 because there is minus here. Then we have e to the power minus 2x divided by 4 plus the c. So since we want to get the general solution, we need to make y the subject. So divide through by e to the power minus 2x. So this is going to be minus 2x divided by 2 minus 2x divided by 4 e to the power minus 2x plus c divided by e to the power minus 2x. And this will cancel this will cancel that. So we are going to have y to be minus x over 2 minus 1 over 4 plus c e to the power 2x. So I have the minus here, so I can move it up there to make it positive. So this is the general solution. This is the general solution. But we were given initial condition, so it means that we need a particular solution too as well. So let's try and find a particular solution. Now we have y of 0 is equal to 2. This implies that s is equal to 0 and y is equal to 2. So let's plug this one inside this to find the c to get our particular solution. So this is going to give us 2 is equal to 0 minus 1 over 4 plus c e to the power 0, which is going to give us 1. So when I plug in 0 here, this will be 0. I have this one here, and 0 here, e to the power 0 is 1. So we are going to have 2 is equal to minus 1 over 4 plus c, and c will be equal to 2 minus 1 over 4 plus 1 over 4, and this is 9 divided by 4. So our particular solution is going to be y is equal to minus x over 2 minus 1 over 2 plus 9 over 4 e to the power 2x. This is the particular solution that we are going to get for this particular question. So this is what you are going to get for the first question here. This is what you are going to get for the first question. Let's look at the next question here. Don't forget we have 7 questions that we are going through, and then stay here too so that we can just go through them together. Now this one, first we want to show that x squared y squared to the power minus 1 is the integrating factor, right? So what we just need to do is we need to multiply this through the differential equation, and then we see what we are going to get. But don't forget, I can write this one as 1 divided by x squared plus y squared. So I'll use this one to multiply through this. So when I do that, I'm going to have x plus y divided by x squared plus y squared dx plus y minus x divided by x squared plus y squared dy is equal to 0. And this is of the form m dx plus n dy is equal to 0. So for integrating factor, for us to show that it is an integrating factor, we need to show that when I differentiate m with respect to y is the same as when I differentiate n with respect to x partially. So now let's pick our m. M here is equal to x plus y divided by x squared plus y squared, and our n is equal to y minus x divided by x squared plus y squared. So we need to now differentiate this with respect to y and differentiate this with respect to what? X. So let's do that. But don't forget here we are going to differentiate it partially. So differentiating m with respect to y is going to be, now we are going to use the quotient rule, but this one partially. So this is going to be maintain the one on the top, maintain the one at the down, then differentiate the top. So when I differentiate the top with respect to y, when I differentiate x, it will go to 0. And when I differentiate y, I'm going to have 1 minus, now maintain the top and differentiate the denominator. And when I do that, I'm going to have 2y because we are differentiating with respect to y. All divided by x squared plus y squared all squared. That's the quotient rule. So let's simplify and see what we are going to get. This is x squared plus y squared minus 2xy minus 2y squared divided by x squared plus y squared all squared. And finally, we are going to have x squared minus 2xy minus y squared divided by x squared plus y squared all squared when we simplify this one right here. So now for us to say that that is indeed the integrating factor, then when I differentiate this with respect to x, I should be able to also get the same thing here. So let's do that one too and see what we are going to get. So we want to differentiate n with respect to x. Our n is equal to y minus x divided by x squared plus y squared. So go through the same process. Maintain the denominator x squared plus y squared and differentiate the numerator, but now we are going with respect to x partially. So when I differentiate y, 0. When I differentiate minus x, I'm going to have minus 1 minus, now maintain the top and differentiate the down. When I differentiate x squared, I'm going to get 2x, but when I differentiate y squared, I'm going to get 0. Then divided by the denominator squared. So that's what I'm going to get. Let's try and simplify and see if we are going to get the same thing. So minus x squared minus y squared, when I multiply this, then this is going to be minus times this is going to give us 2xy. Then minus times this is going to be plus 2x squared divided by x squared plus y squared all squared. So let's try and simplify it. This plus this is going to give us x squared minus 2x squared minus 2xy minus y squared divided by x squared plus this all squared. So this and this is giving us this. This is here and this is also here. So we can see that this is the same as this. So here we can conclude that hence the differential equation is exact, and it shows that the function or the mu is indeed the integrating factor. So if that is the integrating factor, so we are saying that hence we are concluding that hence the differential equation is exact, since when I differentiate m with respect to y is the same as n with respect to x partially. Thus mu, which is equal to 1 divided by x squared plus y squared, is the integrating factor. Now we are not done. The question is saying that if it is integration factor or integrating factor, then we need to find its general solution. So now let's go through how to find a general solution from this. Right? So here what we are going to do is, since it is exact and it is integrating factor, then there exists a function that when we differentiate, we are going to get the function there. So there exists a function. Let me say the function is f of x, y. Now such that when I differentiate this function here with respect to x, I'm going to get m. And when I differentiate the same function with respect to y, I'm going to get the n, right? Which is here. So I have my m here, I have my n here, right? So that's basically what I'm going to get. I mean, when I differentiate f with respect to x, I'm going to get what is here. And when I differentiate f with respect to y, I'm going to have what is here, because this function here is basically how we write this one as differentiate the function that we are talking about with respect to x partially and going with the x plus this with respect to y going with y is equal to 0. So what is here is basically differentiating f with respect to x, and what is here is differentiating the function with respect to y. This, when you are doing something, a course that we call it advanced calculus next semester, you are going to think of, like, you are going to do something called total differentiation, and this is how total differentiation goes. Good. So now we know that m is equal to x plus y divided by x squared plus y squared, and we know that n is equal to n is equal to y minus x divided by x squared plus y squared. So now we can just differentiate them. Equation 1, equation 2. So let's go through quick. Now let me integrate this. Remember, this is in terms of x and y with respect to x. And then also integrate this with respect to x. So basically what I'm doing here from equation 1, I'm using equation 1 first. So from equation 1, I want to integrate equation 1 with respect to x so that I can get the function that we differentiated. So let's do the differentiation. This is differentiated 1. So when I integrate, I get the function out. So I'm going to get something like this. Then I can write this one here as x divided by x squared plus y squared dx plus integration of y divided by x squared plus y squared. So I just divided this one divided by this plus this divided by this here. Then this integration is like we need to pick them one by one and do it. Then we bring them together. So what can we do here? We can write this integration here. Let me use red to do the first one. So x divided by x squared plus y squared dx. I see that this is a length function because I have x down here and I have x2 on the top here. So let's see how the length function will come. I will let u to be equal to x squared plus y squared. Now remember, we are dealing with partials, right? So we are going to differentiate this partially, but I'm going to use the ordinary sign. So this is going to be du over dx, which is equal to 2x. Because when I differentiate y with respect to x, since it is partially, it's going to be 0. Now let's make dx the subject. So dx will be equal to du divided by 2x. So that's what I'm going to get. So let's try and put them in. This is going to be x divided by x squared plus y squared is u. So I'm going to have the u here times dx is equal to this. So I'm going to have du divided by 2 dx. So sorry, du over 2x, and this will cancel out. So I'm going to have 1 over 2 integration of 1 divided by u du. So when I integrate 1 over u, I'm going to get the natural log function. So I'm going to have this natural log of u. I'm not going to add plus c, right? Because I'm not done with the integration. So I'm not going to add plus c. I will tell you something. Now what is u? U is equal to this. So I'm going to have 1 divided by 2, the natural log of x squared plus y squared. So this is the first one. Now let's consider the second one, right? Let's consider the second one also here. Now we want to also integrate y divided by x squared plus y squared dx. Here, because it's going with respect to x, I can factor y out and have 1 over x squared plus y squared dx. Now I see that this is going to give us tan inverse because I have 1 divided by something squared plus a constant, which I can make the constant 1. So I can write this one as let s to be equal to y tan of theta. Why did I choose this? I chose this because now when I square this, let's square this one and see. When I square this, both sides, I'm going to have x squared, y squared, then tan squared theta, right? So that when I put it here, I can factor the y out because y will be common on both sides. And then you will see, so when we are doing substitution, you will see what I was trying to do. So let me bring this one here. Let me bring this one here. So when I square it, this is what I'm going to get. So let me put the square on the top. Now let's differentiate this with respect to theta because that's our new function. So dx over the theta will be equal to y is constant. So I maintain it there. I differentiate tan and I'm going to get sec squared theta. And then when I make dx the subject, I'm going to have dx is equal to y sec squared theta d theta. So now let's just do, substitution and see what we are going to get from here. Now this is going to give us something like this. So let me shift this one small here. This is going to give us y integral of 1 divided by, now x squared here is equal to this. So I'm going to have y squared tan squared theta plus y squared times the x is equal to this. So I'm going to have y sec squared theta d theta. Now I can multiply this y to this y. I'm going to have y squared, then 1 divided by, now I can factor y squared out and have y squared tan squared theta plus 1 times sec squared theta d theta. So that this will cancel this. Indeed, good. Then I'm going to have integration 1 divided by, now tan squared plus 1 is the same as what? Sec squared. So I'm going to have sec squared theta times sec squared theta d theta, sorry. And then the magic happens. They are going to cancel out. And then my integration is now just integrating 1, right? And when I integrate a constant, I'm going to get the constant times what I'm integrating with respect to. So this is going to be theta. Now the function that we are integrating was in terms of x and y. So our final answer should be in terms of x and y, not theta. So we need to go and look for theta. Now, where can we get theta? We can get theta from where we made x to be equal to y is equal to tan theta. So we know that x is equal to y tan theta. Divide through by y, and we are going to have tan theta is equal to x divided by y. Make theta the subject by taking tan inverse, and we are going to have tan inverse of xy divided by this. So this is equal to tan inverse of x over y. So that's the reason why I was telling you that this is going to give us tan inverse. So now let's combine the integration together. Let us combine the integration together. Now combining the integration together, we are going to have something like this. So now we have f of x, y to be equal to, so what was the first one? This one was equal to this, right? But the first integration we had this, and the second integration is what we had there. So this, our f of s is going to be 1 divided by 2, the natural log of x squared plus y squared, plus the last one that we had here, which is this tan inverse of x over y, plus, now, we need to add a constant to it, right? But this one, since we are differentiating it with respect to two variables like x and y, and this one we integrated with respect to x, then our constant should depend on the other variable that we didn't know what integrate with respect to. So this is going to be a of y. So this is the function that we were using, but we need to go and look for a of y. So now you can see that now we've used equation 1. We need to make use of equation 2. So for us to make use of equation 2, our new equation that we have gotten, we need to differentiate it with respect to y so that we can get f of y from the new equation that we had from there. So let's try and differentiate the function and see what we are going to get from there. Let's try and differentiate it and see what we are going to get from there. So let me call this one equation star, because that's our final equation that we are going to use. So now let's differentiate this with respect to equation star with respect to y. So f of y will be equal to 1 divided by 2. Now, when I differentiate a length function, I'm going to have 1 divided by what is inside the parenthesis, which is x squared plus y squared, times, then I differentiate what is inside the parenthesis, right? But remember, I'm differentiating with respect to y. So when I differentiate x squared, it gets to 0. When I differentiate y squared, I'm going to get 2y. Plus, now I need to integrate tan inverse of 1 over 2. Sorry, x over y. But don't forget, if I want to differentiate tan inverse of, let me say, tan inverse of u, this is equal to 1 divided by 1 plus u squared times differentiating u. So this is how it is. So here, when you compare this to this, we can see that our u is now equal to x over y. So when I'm doing substitution, this is going to give us something like this. 1 divided by 1 plus x over y squared times, then I need to differentiate what is inside the parenthesis, which is x over y. So this is how it's going to be. So further calculus. So now let's see what we can do here. Now I'll add plus. Now we are going to differentiate this. This is one variable, so we are going to use the ordinary differentiation. So this one is going to be a prime of y. So now let's try and simplify this and see what we are going to get. These two will cancel these two. So f of y will be equal to y divided by x squared plus y squared plus, now I can write this one as 1 divided by 1 plus x squared divided by y squared times, now I need to differentiate this with respect to y, not x, because we are going with respect to y. So now differentiating this with respect to y, let me write this one very well. So 1 x divided by y is the same as x y to the power minus 1. So let's differentiate with respect to y. This is going to give us minus 1 drop xy, then I subtract 1 from it, so I'm going to have minus 1 minus 1, and this is going to give us minus xy to the power minus 2, and this is also the same as minus x divided by y squared. So when I differentiate what is inside the parentheses here, this is what I'm going to get. Now x here is constant, so don't think about the x. You can factor x out and just differentiate 1 over y, and this is what we are going to get. So this is times minus x divided by y squared. Now let's see what we can do here. Now this is going to give us something like this: y divided by x squared plus y squared plus, now I can simplify this to get 1 divided by y squared plus x squared divided by y squared times minus x divided by y squared. Good. Now this is the same as y divided by x squared plus y squared plus, now because 1 divided by the, I can reciprocate it and have y squared divided by x squared plus y squared. Addition is commutative, so I can bring the x before the y. Then I'll multiply it by minus x divided by y squared. And now this guy will cancel this guy. So I'm going to have something like y divided by x squared plus y squared minus x divided by x squared plus y squared when I multiply this by that. This is a long solution. Now the denominator is the same, so I can combine this to have y minus x divided by x squared plus y squared. You know, I left something out. This one, thank God I remembered. So remember, there is a plus of this one here, so we need to be adding it to it. A prime y plus a prime y, a prime of y plus a prime of y plus a prime of y. Good. So this is f of y. Let me call this one equation 3. So we have f of y here, and from equation 2 we have f of y here, which is equal to this. So it means that equation 2 is the same as equation 3. So equate equation 2 and 3. Equate equation 2 and equation 3 and 2. So I'm going to have, remember this is equation 3, right? So we are having y minus x divided by x squared plus y squared plus a prime of y, which is equal to, equation 2 was equal to this from the equation, so we are going to have y minus x divided by x squared plus y squared. So when I move this one to the right side, I'm going to have it to be negative, and it's going to cancel out. So I'm going to have a prime of y to be equal to 0. So a prime of y was the thing that we are looking for. So now let us integrate, since it is being differentiated with respect to y. So integrate both sides with respect to y. This is going to be a of y. And then when I integrate a 0, I'm going to get a constant. Because remember, when I differentiate a constant, I get 0. So when I integrate a 0, I need to get a constant. Let me call it c. So now we've gotten a of y, right? That's what we are looking for. So now let's go up there and look for our equation star. So this will be the equation, but now a of y is equal to constant, and then we are done from there. So let's go and see what we are going to get from here. So finally, f of xy is equal to 1 over 2 natural log of x squared plus y squared plus the tan inverse of y divided by x plus a constant c, because this one was a of y. Now what we just need to do is, let me make this one c naught and then this one to c naught, so that I can now change my f of xy to c1 because it's supposed to be a constant, and then this squared plus tan inverse of y divided by x plus c naught. Then I'll move the c naught to this side. So I'm going to have c1 minus c naught, and then a constant minus a constant is the same constant. So I'm going to write this one as c is equal to 1 divided by 2 natural log of x squared plus y squared plus the tan inverse of y over x, where c is equal to c1 minus c naught. So this is what we are going to get for our second question. Now let's look at the third question here. Now our third question here too, it's kind of like first order linear equation or linear first order differential equation, because we have it to be differentiated first one. So as I said, always remember, so y prime plus gen of x y should be equal to h of x, and then our mu is equal to e to the power integral of gen of x dx. So what can we do here? Now when we compare this to this, I can just write this one as dy over dx plus 2x divided by 1 plus x squared times y. So I just brought the y here, which is equal to cos of x. When we compare this to this, we can see that gen of x is equal to 2x divided by 1 plus x squared. So that's what we are going to get. So now let's find mu, that is the integrating factor, and then we continue from there. So we are going to have mu to be equal to e to the power 2x divided by 1 plus x squared dx. This one is going to give us ln, but I'm going to do it step by step using the u substitution. So I'm going to let u to be equal to 1 plus x squared, differentiate with respect to x, and we are going to have this. Let's make the x the subject. This implies that du is equal to 2x dx, and dx will be equal to du divided by 2x. So that's what we are going to get. So now let's plug them in and see what we are going to get from here. So this is the same as integration 2x divided by, now 1 plus x squared is the same as u, which is here. So this one, I'll put the u here, times the x is equal to this. So I'm going to have du over 2x. And then 2x will cancel 2x. So I'm going to have something like this. I'm going to have e to the power 1 over u du. And when I integrate 1 over u with respect to u, I'm going to have this. Now, since e and ln are inverse, this is basically going to give us u. And what is u? We saw that u is 1 plus x squared, right? Very nice. So we are going to have 1 plus x squared. So this is the integrating factor. So we are going to use the integrating factor to multiply through this equation here. So let's do that. We are going to have 1 plus x squared times dy over dx plus 2x over 1 plus x squared. Is that right? Yes. Y times 1 plus x squared, which is equal to, then we use that one to also multiply this, which we are going to have 1 plus x squared cos x. So we just solved one example which was like linear form like this. So we need to ignore this by focusing on this. So what we are going to do is we are going to multiply the y here to this. So having y 1 plus x squared, then we are going to multiply this one by dy over dx. So dy over dx in square bracket. So you just pick this one to multiply this, which is going to give us this. Then dy over d over dx will be here. And this one will be equal to 1 plus x squared cos x. So we just ignore this in the context that when I use the product rule here, when I do it, I'm going to get everything here again. Good. So now let's try and then integrate both sides. So let's go integrate both sides with respect to x. So I'm going to have 1 plus x squared times y dx, integrate 1 plus x squared cos of x dx. So this cancel this cancel that. 1 plus x squared y, which is equal to. Now I can write this one as, I can multiply through by the cos. So I'm going to have cos of x dx plus another integration. Then I multiply this one by this. I'm going to have x squared cos of x dx. So here we need to take the integration one by one, right? But fortunately for us, we can see that the first one here, when I integrate cos, I'm going to get sine. So this one is very simple to see. So now our headache here is this. Our headache here is this one. So here what we just need to do is, now we are going to use integration by part 2 times. We are going to do integration by part 2 times before we can get our function. So now let me consider x squared cos x dx, and then remember integration by part, u dv, which is equal to u v minus v du. Now here our u is equal to x squared and our dv is equal to cos of x dx. So anytime I'm dealing with integration by parts and I have a polynomial function and an trig function, I choose my u to be the polynomial function and I choose my dv to be the trig function with the dx. So now let's look for du and let's look for v. So this will be 2x and du will be equal to 2x dx. Now when I integrate both sides here with respect to, when I integrate both sides, I'm going to have v to be equal to, when I integrate cos s, I get sine x. So that's what I'm going to get. So let's use integration by parts to finish this. So we need to u times v. So u times v, I'm going to get x squared sine x minus v times du. So v times du. So I'm going to have sine x times 2x dx. So this is what I'm going to get. But now, mind you, what we are going to do here, let me just pick this one down here. Let me just move it down so that we can continue. Now, we are going to have this one to be squared sine of x minus, I can factor 2 out and have x sine. Now, I have another polynomial function and trig function again, so I need to use integration by part again. So here, I'm going to pick my u to be equal to x and dv to be equal to sine x. Let's look for du over dx from here. So du over dx is going to be 1 and du will be equal to dx. Good. Integrate both sides. Oh, this one should be going with dx. Sine x dx, and my v will be equal to, when I integrate sine x, I'm going to get minus cos x. So that's what I'm going to get. So on this side, I'm going to have my integration should be, so this one is equal to cos x squared cos x dx will be equal to, I have this one already here. So I'm going to have x squared sine x minus 2, open bracket. So now what is inside this is what I'm going to use the integration by part. So u times v minus s cos of x minus v is minus cos x and du is dx. So this is what I'm going to get. X squared sine squared x, then minus 2 minus x cos of x, then plus cos of x dx. So when I integrate cos x, what am I going to get? I'm going to get sine x. So this is going to give us sine x minus 2 minus x cos of x plus, when I integrate cos s, I'm getting sine x. So finally, x squared sine x plus 2x cos s minus 2 sine x. So this is for this aspect, this one here. So now I'm going to write everything again. So look at what we have here. So I'm going to write this one plus this plus the final answer that we have gotten down there. So we are now having 1 plus x squared times y, which is equal to, well, the first one was we're integrating cos and we had sine, good, plus the whole of this. So let me just go and check if I wrote the right thing. Okay, so I have this one here plus this. So plus the whole of this. So we are going to have x squared sine x plus 2x cos x minus 2 sine x plus a constant c, right? So now we are almost there. Let's find y. So find y by dividing through by 1 plus x squared. So this is going to be sine x divided by 1 plus x squared. Or I can just, yes, I can just write everything like this. Sine x plus x squared sine x plus 2x cos x, all divided by 1 plus x squared plus c divided by 1 plus x squared. I can just stop here and say that this is the general solution. But they gave us initial conditions. So what we just need to do is we need to go ahead and just use it. So what is the initial condition? Y is 2 and x is 0. Y is 2, x is 0. So let's go through. Y is equal to 2, x is 0. 2 is equal to sine 0 is 0. This one will be 0. This one will be 0. This one will be 0. So this part is going to be 0. Plus, now when I plug in 0 here, I'm going to have c over this. So this is going to be 2. Sorry, it's going to be c, and c is going to be 2. Right? So that's what we are going to get for c. That's what we are going to get for c. So c is going to be 2. Now, since c is equal to 2, we can just plug it in and we are done. Right? So let me just maintain and write it here. So this is going to be sine x plus x squared sine x plus 2s cos s divided by 1 plus x squared plus 2 divided by 1 plus x squared. This is the particular solution. Good. So this is the particular solution for this. So one tip for you, whenever you are doing it, you need to pay attention, right? Because this one is kind of frustrated, most especially when you are in the exam room. You know, sometimes you get stuck somewhere. Relax and try to recall and practice very well so that you'll be able to, you know, do them very well. Now let's look at this one. This one is second order, right? This question that we have here is second order homogeneous, right? So what we just need to do is let's try and pick the homogeneous aspects to find the complementary solution. And then when we get a complementary solution, we can think of finding the particular solution, then we add it to get the general solution. So let's go through. So for complementary solution, y prime prime plus y prime minus 6y should be equal to 0, as we know. So now we need to pick y to be equal to e to the power mx. So y prime will be equal to m e to the power mx, and y prime prime will be equal to m squared e to the power mx. So now let's plug them inside this, and we are going to have m squared e to the power mx plus m e to the power mx minus 6 e to the power mx, which is equal to 0. So this is what we are going to get from here. Then here we can factor e to the power mx out, and it will be left with m squared plus m minus 6, which is equal to 0. So here we can pick the characteristics equation by saying that e to the power mx is never 0. Then we get the characteristics equation is equal to 0. So this is the characteristics equation. Then since we've gotten the characteristics equation, we need the characteristics root, right? So what can we do here? We can pick two numbers that when you multiply, we get negative 6. And then when we add, we get 1, the coefficient of this. So you can use calculator to solve that, but I'll write it for you. So this one is going to be m squared, let me say, minus 2m plus 3m minus 6 is equal to 0. So this is true. 3 times minus 3, minus 2 times 3 is 6. and then minus 2 plus 3 is 1. So this is m out, m minus 2 from the one that I've underlined with blue, and then the one that I've underlined with green, I can factor 3 out, and it will be left with this. Factor m squared, m minus 2 out, it will be left with m plus 3, which is equal to 0. So here, m will be 2, and m will be equal to minus 3. So this is two distinct real values, 2 and minus 3. So the trial solution for our complementary solution will be y of c to be equal to a constant. Let me use a, e to the power m1 x plus b, e to the power m2 x. So let me call this one m1 and let me call this one m2. So that's what I'm going to get. So the complementary solution will be equal to a, e to the power 2x plus b, e to the power minus 3x. So this is our complementary solution, right? Now that they've gotten complementary solution, we need to think about getting the what? The particular solution. So this is what we just need to do. Now for particular solution, we need to look at the non-homogeneous aspect. And looking at the non-homogeneous aspect, we need to compare it with the what? The complementary solution. So what is the non-homogeneous aspect? X squared e to the power x. X squared e to the power x. So this is a polynomial function and an exponential function. So the polynomial function is to the power squared. So let's have something what is to the power squared. So I can have a0 plus a1x plus a2x squared, right? So this is a quadratic, a polynomial function with a degree 2, and then we multiply it by the exponential function. But what we just need to do is we need to compare if this is with the exponential function. But we see that the exponential function here is just e to the power x, and this is minus 3, this is 2. So even when I multiply, there is no term here which is going to be the same as this. So this becomes our trial solution. So what we just need to do is we need to differentiate this, plug it inside the original function, and then we find our constant a0, a1, and a2. So let's do that. Let's do that. This is going to be a lot, but let's try and do it. So this is going to give us, so this one like this, we can use variation of parameters. It's going to be very short, but we are using undetermined coefficient. So let's do that. So this is the same as a0, this is the same as a0 e to the power x plus a1 x e to the power x plus a2 x squared e to the power x. So let's do the differentiation. When I differentiate this, I'm going to have e to the power, the same thing again, plus this is the product rule. So maintain e to the power x and differentiate x, get 1, plus now I maintain a1 and x and differentiate e to the power x and still get the same thing again. Then plus I need to use product rule again here. I'm going to maintain a2 e to the power x and differentiate x squared. So I'm going to have 2a2x e to the power this when you differentiate x squared. Then plus, now you maintain a2x squared and differentiate e to the power x and get this. So let us simplify before we do the rest. So a0 e to the power x, I can add this to, I can simplify. Okay, I can't simplify, so I think I just need to leave it like that. So let me just go with prime. Differentiate this one, get the same thing, a0 e to the power x, plus differentiate this one again, the same thing, e1 e to the power x, right? Good. Then differentiate this one is product rule again, so plus a1 e to the power x. When I differentiate x, now maintain a1 x and differentiate e to the power x, we get the same thing. Come here again, differentiate it, maintain 2a2 and differentiate x, you get this, plus now maintain 2a2 x and differentiate e to the power x, you get the same thing, plus differentiate this, which we differentiated here and we had something like this. So this one is going to give us 2a2x e to the power x plus a2x squared e to the power x. So maintain e, and this one differentiate this, giving us this. then maintain this and differentiate this, giving us that. So now we are done. But I can group some like terms, right? Yes, of course. This one can be written as, let's say, a naught e to the power x. I can add this and this to get plus 2a1 e to the power x. And then can I add anything again? No. So plus a1 x e to the power x. Then I think I can add this guy and this guy together. So I'm going to have plus 2a naught a2 e to the power x. Then when I add this and this, are they the same? Yeah. I'm going to have plus 4a2 x e to the power x plus a2 x squared e to the power x. So now let's go and plug this one inside the original function, this, and see what we are going to get. Compare, and then we see how we can go through the process very successfully. So we have y prime prime. So y prime prime means that we need to write the whole of this as y prime prime, right? So let me write the function again. Y prime prime plus y prime minus 6y is equal to x squared e to the power x. I hope that's the right equation. Yeah. So we want to plug in y prime prime, this, the whole of this. So for me, I'm going to do copy and paste so that we can go fast. So copy this one and paste it here. So this is y prime prime. This is y prime prime. So let me just move this one to here. Then plus this. Then plus y prime. So what is y prime? We have, where's y prime? Y prime is right here. So I'm going to also copy that one and paste it. Y prime is here. Good. So let me just paste it somewhere here. So this is going to be y prime. Good. So I'm going to add plus y prime. Then minus 6 times y. So this is y. So I'll multiply it through straight. So I'm going to have this one. Then we'll copy it and send it there. 6 times y. So this is going to be times. So I'm going to have something like this. This here, this a lot. But let's pay attention here. We can do it. We can do it. So now don't forget I'm multiplying through by minus 6. So I'll just move this one a little bit and have this one to be minus 6 attached to it. And then this one too is going to be minus 6 a2 x squared e to the power x, which is equal to the function x squared e to the power x. So what we are going to do is we are going to group all like terms, the one with in terms of x, e, x squared, e, and constant with e. And then we just focus on that. So let's do that. All the one with just a constant and e to the power x, let us underline them. We have this one to here. We have this one to here. We have another one again. We have another one here. We have another one here. And we have another one here. So we are going to combine all those with red. So this, and I can see that I can even add this and this, right? So let me add this and this. Can I add another one again? And this one. So this is going to give us minus 4a naught e to the power x, right? And then this and this is going to give us plus 2a1 e to the power x plus 2a2 e to the power x. And let me just simplify this one straight. I'm going to have minus 4a naught plus 2a1 plus 2a2 all times ex when I factor es out. So that's what I'm going to get for the first ones. Now let's look for the terms with x and ex. I'm going to underline with green. This one too is the same. Do I have another one here? I have another one here. I have another term here. Good. So all the ones with the green are the one with e and x. So can I add some of them? Yes, of course, I can do that. So I can add this and that and this one. So this is going to give me minus 4a1 x e to the power x, right? Then what will be left? It will be left with the one with greens. It will be left with this guy and this guy. Are they the same? Yeah, this guy and this guy are the same. Yeah, so I can add it and get 6. So plus 6 a2x e to the power x. Is that true? I don't want to make a mistake. Okay, it's true. So I can add this and this. So all the green ones too are gone. So I can rewrite this one as minus 4a1 plus 6a2 all times x e to the power x. So I can clean this one and then put it there. So plus this one also there, right there. Then the last one is the one with the x squared, right? So one with the x squared, we have this, this, and this. They are 3, right? 1, 2, 3. Good. Can I combine any of them? Yeah, I think this and this are the same. And then I think the same thing to this one. So when I add this and this, I'm going to get 2 plus this is going to give us minus 4. So minus 4a2 x squared ex squared is equal to x squared ex. So that's basically what we are going to get. So let's try and then see if we can, simplify this. So now let's compare left to right. Now the right has only x squared and e. And we can see that we have x squared and e here. X squared and e here. So the coefficient of this is 1 and the coefficient of this is minus 4a2, which is equal to 1. So a2 will be equal to 1 divided by 4, minus 1 divided by 4. Now with this one, we don't have any function with e to the power this, so we can say that it's 0. So this one will be equal to 0. So you are going to have minus 4a1 plus this is equal to 0. But we know that a2 is minus 1 over 2, so we can plug it in and then we just solve it from there. So minus 4a1 plus 6 times minus 1 over 4, which is equal to 0. Minus 4a1 plus, minus 6 over 4. So this is 3 over 2 is equal to 0. Good. a1, minus 4a1 is equal to minus 3 over 2. Divide through by minus 4 and a1 should be 3 divided by 8. So that's what they are going to get. No, this one's supposed to be positive so that we can get this one to be minus. Yeah. And then the last one is this guy. Let's try and find that guy too. This is a lot. So we are still preparing for our final exam. So minus 4 a naught plus 2a1 plus 2a2 is equal to 0. So we know a1 to be minus 3 on 8, and we know a2 to be minus 1 on 4, which is equal to 0. So let's try and figure it out. So minus 4a naught will be equal to, will be minus 3 over 4, because when I cancel this one will be 4. And then this one too is going to be minus 1 over 2, which is equal to 0. So that's what we are going to get. So let's try and figure out how we are going to get it. So minus 4a naught is equal to, and when I add this one is 4 and this one is 2, I'm going to have minus 6 on 4. Is it minus 6? No, minus 5 on 4. So this will be 5 on 4. Divide through by, divide through by, is that right? What I'm doing, is that right? Let me see. The one with constant a, we had this going with this giving us 4, going with this one to giving us 4, and then we had a1. Okay, we have a1 here. We have a1 here, so this one should be 3. We have a1 here. So this one should be going together. I didn't say it from there. So this one and this one should be going. So the one with the a1 will be 3. The one with a1 should be 3. Yes, should be 3. So it means that this one should be 3. Where is it? A1 should be 3. So this is going to be 9 divided by 8. Good, indeed. 9 divided by 8. And then now this one is 8, 4. So this is going to be minus 13. So this is going to be 13 divided by 8, indeed. Then when you divide through by minus 4, This is going to give us minus 13. Then 4 times 8 is 32. So we've gotten A naught to be this. A1 is minus 3 on 8. And then A2 is equal to minus 1 over 4. So we are going to plug it inside our trial solution, which is this. This is our trial solution, right? So let's plug it in and see what we are going to get from this. We are going to have YP to be equal to minus 13 over 32 plus, minus 3 on 8x minus 1 on 4x squared, all times e to the power x. So this is our trial solution. We add the trial solution to the complementary solution to get the general solution. So our general solution is YC. Y is equal to YC plus YP. Now we know that YC is A e to the power 2x plus B e to the power minus 3x. Then plus we add the particular solution to it, which is going to be this. So let me just copy and paste. Paste it. Boom. There we are here. Good. So this is what we are going to get for our particular solution. There is a lot of work here. This is a lot of work. This is a lot of work. Now let's look at the next question. We have, so when we are done with this one, we have 2 more questions to go. We have 7 questions. So let's just move very fast. So what can we do here? Here is very simple. We have x squared plus y squared dx. So I can move this one to the right and have x divided by x squared plus y squared dy. Very simple. So this one we are using separable, right? Now what I can do here is I can multiply through both sides by x squared plus y squared. Multiply this one too by x squared plus y squared. So that this will cancel this and this too will cancel this. So I'm going to have y dx is equal to x dy. Then separable, group like terms. So I can write this one as 1 divided by x dx, which is equal to 1 divided by y dy. So I divide through by x. When I finish, I divide through by y. So that's what I'm going to get. We just do the integration from here. Integrate this one too. So this is going to give us natural log of x plus, you can add constant here, but I'm just going to add the constant to one side, plus c, or let me say c1. So that's what we are going to get. And we can write this one as, let me say, I can move, okay, let me add another constant to this so that it can be nice. So plus c naught. So this minus this is equal to c naught minus c1. So I just move this one here and move this one also here. Now, when you are using the law of logarithm, this can be written as y over x, which is equal to, I can write this one as c. So a constant minus a constant is a constant. So I can write this one as c. Then what I can do here is I can pick, or I can pick e on both sides, y on x, which is equal to e this. And then I can write this one as inverse. Ln and e is inverse, so this is the same as this, which is equal to e to the power a constant is also a constant, so I can call it a constant k, and here y will be equal to kx. So this will be the solution for this question. This one is pretty straightforward. Let's talk about question 6. Let's talk about question 6, and let me see if I can leave you with, let me see, question 7 or something like that. So let's talk about question 6. Now question 6, we want to find a general solution, and this is the second order, right? So let's go through, but we have something that we are going to use here. Now d squared r over dt squared plus 2 alpha dr over dt plus omega squared r is equal to 0. So we know how to do it. Our function here is r, so we are going to set r to be equal to e to the power mx. So let's go through the process. So, or I can say that, yeah, so dr over dt will be equal to m e to the power mx, and then d squared r over dt squared is equal to m squared that. So let's do substitution as we do for the So this is going to be m squared e to the power mx minus, no, plus 2 alpha m e to the power mx plus omega squared e to the power mx is equal to 0. So this is what we are going to get after we have done the substitution of this one inside this. Let us factor e to the power this out. So m squared plus 2 alpha m plus omega squared is equal to 0. So this is what you are going to get. So let us get our characteristics by saying that e to the power m is never 0. And we are going to have m squared plus 2 alpha m plus omega squared to be equal to 0. So now here we need to find the root. So we need to use the quadratic formula because we don't have exact values for this. So when you compare this one to the quadratic, which is ax squared plus bx plus c, we can see that the coefficient of x squared and m squared, this one is 1. So here a is 1, and the one with the x, which is going with m, b is equal to 2 alpha, and then c is equal to omega squared. So using the quadratic, we are going to have m, which is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So let's do substitution to solve this. M is equal to b is 2 alpha plus or minus square root of, now b squared, so alpha squared minus 4 times a, which is 1 times c, which is omega squared, divided by 2 times 1. We are going to do something here which we need to pay attention here. So this is the same as 4 alpha squared minus 4 omega squared divided by 2. Now I can factor 4 out here. So I'm going to factor 4 out. So I'm going to have 4 alpha minus this divided by this. And when I pick square root of the 4, the square root of 4 can come out as 2 and have alpha squared minus omega squared divided by 2. Now, since this one is divided, I can cancel this and that. Or in other words, I can write this one as minus 2 alpha divided by 2 plus or minus 2 alpha squared minus this divided by 2, so that I can cancel this and this and this and this. So this is minus alpha plus or minus square root of alpha squared plus. But there was a condition given to us, very important. There is a condition that omega squared minus alpha squared is positive, is greater than 0. So what we just need to do is we need to make sure that we have that thing there. The question is saying that omega squared minus alpha minus what? What's the question again? Omega squared minus alpha squared is positive. This one is greater than 0. So what we are going to do is we need to make sure that we have this one of this form. So I can write this one as minus alpha plus or minus this. Now I can factor minus out and have it to be omega squared minus alpha squared. So that when I multiply through by minus, this one becomes minus omega squared, and then minus minus becomes positive from here, right? But now we know that this guy here is positive. So it means that when I subtract alpha squared from omega squared, I'm going to get positive value. Now we know that square root of minus is I, right? So it means that this is going to give us minus alpha plus or minus I square root of omega squared minus alpha squared. Knowing that now when I do this, since this one is positive, then this one becomes a positive value. So there is no way this is going to give us a complex value again, right? So that's basically what we are going to get here. So now our solution is in the form of complex. And what we are going to do is we are going to use a trial solution for complex. So this is like u plus or minus iv. So what is the trial solution for our general solution? It is e to the power ux, then in brackets, let's say k1 cos of ven x plus k2 sine of ven x, this. So here, our u is alpha, and our ven is square root of omega squared minus alpha squared. So we just plug them in and then we are done. But let's see, the function is in terms of t, right? So we need to use t, right? Because the function is differentiated with respect to t. So let's use t here instead of x. So t This one should be T, this one should be T, and this one to be also. So always pay attention. So this one is going to give us, this one should be minus e to the power minus alpha t in bracket k1 cos of t, or square root of omega squared minus alpha squared t, plus k2 sine of omega squared minus alpha squared t. So this is our general solution that we are going to get from this question. Okay, so I have the last question that I'm going to, give it to you to try, right? So first question is showing that this is show that this is exact, right? So we have this one in the form. I'll just leave it to you to try. I'm just showing you something here. Plus sine x dy is equal to 0. So this is of the form m plus n dy. So pick your m to be x plus y cos x and your n to be equal to sine x, and go through the process and leave your final solution in the comment section. So in the next video, we are going to tackle vector algebra. So the previous video and this one is differential equation. So the first one we looked at objectives, and this one we looked at section B. So in the next video, we are going to tackle vector algebra, which is objectives. Then after that video too, we tackle section B, so that you can now go and write your exams with confidence. So see you in the next video.